Hi everyone, in this video we are going to solve this example. So that example says we have this equation and we have to prove that this equation has three solutions in this interval -4, 4. Okay. So let us start to solve this example. See, I am going to solve this example with the help of intermediate value theorem. So first of all, we will try to understand the meaning of it and then we will start to solve problem. Okay. So that theorem says, suppose this is y-axis, this is x-axis. So we have some interval a comma b. We have a continuous function f. Okay. At point A, the function has positive value. F of A is positive. At point B, the function has negative value. Negative value. Negative value, that means below the x-axis. The function is continuous. It will be like this. Then that theorem says there exists some point C where the function has exactly value 0. There exists some C between these points A and B such that function has value 0. See, not necessary the first one is positive and second one is negative. Okay, you can take first one is negative and the second one is positive also. Just condition is both should have opposite signs. Okay, and the most important thing is that function must be continuous. Then we can write there exists some point C between A and B where the function has value 0. So using this theorem, I am going to solve this example. So let us have one function. Okay, so consider f from R to R defined as, I am going to consider a function defined as, so yes, I will consider the same function what we have here, polynomial x cube minus 15x plus 1. So this is a function. So now the first question, is this function continuous? Yes, it is a polynomial function, so that's why it is continuous on R. So obviously it is continuous on that interval also. It is polynomial function, so therefore f is continuous on R basically, but see the given interval is -4, 4, so I will mention that interval only. Okay, so let us start to find the value of function at those points. Okay, so let me draw the diagram so the picture will be clear to us. See, it's a rough sketch, So see, at the middle we have a 0, 0. Here 1, 2, 3, 4. On this side we have -1, -2, -3, -4. Okay, so here we have some scaling. Okay, I will not mention. So let us start with this -4. So we have to find three solutions. Okay, between this -4 to 4. Let us find. So consider f of -4 at the x is equal to -4. I am going to find the value of f. Let us put it here. So -4 cube minus 15 into -4 plus 1. -4 cube, yeah, tell me, it's -64, right? Minus plus 60 plus 1. 60 plus 1, 61. So we'll get -3. We are not interested in the value, we are interested in its sign. It is a negative. Okay, that is most important. That means at -4 we are getting some negative value -3. I don't know where it is, but I am considering it will be here. Let us find f of -3. I am considering the next value -3. In the same function, I will put x is equal to -3, -3 cube minus 15 into -3 plus 1. Please help me to find its value. -3 cube minus 27, right? Minus plus 45 plus 1. So -27 plus 46. So it will be 19. Am I right? Yes, it is 19. So it means it is a positive value. At -3, we are getting a positive value 19. It can be somewhere here. Okay, I don't know exactly. It can be somewhere here. So at -4 we are having negative value, but at -3 we are having positive value and function is continuous. So definitely you can find some point C where the function has value 0. So let me mention, therefore by intermediate value theorem, therefore by intermediate intermediate value theorem, there exists some point C. I am calling it as C1 since we want three solutions, no? So first solution is C1 belongs to this interval -4, -3 such that f of C1 is equal to 0. F of C1 means what? Let us put C1 here. C1 cube minus 15 C1 plus 1 is equal to 0. That means C1 is solution of this equation x cube minus 15x plus 1 is equal to 0. So in this way we got our first solution. Actually we want three solutions, so we want two solutions more. Just make a screenshot of it, then I will go further. So let us move further. Okay, let us find the value of f at -2. Now f of -2, see at a place of x I am putting -2 cube minus 15 minus 2 plus 1, it's -8 minus plus 30 plus 1. So it is 23. So it's positive again. Already we have got 19 here and at -2, 23. So again positive, getting positive. Actually we want opposite signs, then only we say the solution is there. Okay, so we are getting positive sign. Let us move further. F of -1. I'm going to find a value at -1. I'm going to put -1 here. -1 cube minus 15 minus 1 plus 1. -1 cube is -1, minus plus 1 minus 1 cancel, 15, positive again. So at -1 also we are getting positive value, -15 somewhere here getting, so that means again positive value, that means no solution. Okay, let us move further. F of 0, let us put 0 here. 0 cube minus 15 into 0 plus 1. So obviously these two will give us value 0 and 1, so that means positive again. So at -1 also we are getting value 1, comparatively small but positive. Okay, we are interested in sign positive. See -2, yes, at 0, no, my mistake. So at 0 we are getting 1, 0 we are getting 1 somewhere here. So yes, graph will be like this. Let us move further. Let us find at 1. So f of 1 I am finding. I am going to put x is equal to 1 here. 1 cube minus 15 into 1 plus 1. 1 minus 15 plus 1, that means -13. We got negative value, getting negative value. At 1 we are getting somewhere here -13. Okay, so at 0 we were having positive value. At 1 we are getting negative value. That means by intermediate value theorem there exists a solution between this interval 0, 1. Okay, let me mention. Okay, therefore by intermediate value theorem there exists some point C2 in this interval 0, 1 such that f of C2 is equal to 0. F of C2, that means let us put C2 here. C2 cube minus 15 C2 plus 1 is equal to 0. That means C2 is a solution of that equation. Therefore C2 is solution of x cube minus 15x plus 1 is equal to 0. That means we got a second solution. Let us go for the third solution. We have reached up to 1. Let us go for 2. F of 2 now I will find. F of 2. Now f of 2. In the same function I am putting 2. 2 cube minus 15 into 2 plus 1. 2 cube 8 minus 30 plus 1. So yes, 9 minus 30 minus 21 negative value. That means -2 again we are getting, plus 2 again at plus 2 we are getting -21. So it will be here. Okay, negative value, no problem. So we want opposite sign, then only we say solution is there. There is no more space to write, just make a screenshot of it, then I will go further. So let us find the value of f at point 3. Okay, so now f of 3. I am putting 3 here. 3 cube minus 15 into 3 plus 1. So 27 minus 45 plus 1, 28 minus 45. So it will be minus 17. Okay, so again negative. Am I right? It's minus 17. Yes, it's minus 17. Negative value minus 17. It was minus 21. No, this is minus 17 will be somewhere here at 3 we are getting, but negative value. Negative value. Let us move further. So our last hopes between this, since here we have already got solution C1, here second point, this is our second solution C2, we want 3 solutions. So this is our last hope, that is we will get some solution between 3 and 4. So let us go for f of 4. 4 cube minus 15 into 4 plus 1. So 4 cube is 64 minus 60 plus 1, 5, positive. So finally we got positive value here. At 4 we are getting positive 5 somewhere here, I don't know. Okay, this is a rough sketch, just showing the signs. Okay, above the x-axis or below the x-axis. So yes, so if you join them, definitely we get a third solution, which is C3. Let me clearly mention, therefore, by intermediate value theorem, there exists third solution C3 belongs to this interval 3, 4, such that f of C3 is equal to 0. F of C3, okay, f of C3, that means here I will put C3 in this equation, the same function we have. So C3 cube minus 15 into C3 plus 1 is equal to 0. Therefore, C3 is solution of that equation, x cube minus 15x plus 1 is equal to 0. So finally we proved, yes, there are 3 solutions. Therefore, x cube minus 15x plus 1 is equal to 0 has 3 solutions in that closed interval minus 4, 4. So in this way we solve this example. Just make a screenshot of it, then we will stop. Thank you. See you in next video.